Hey everyone, and welcome to This Explainer. Today we're taking a really cool visual journey right through the mathematical universe. Now, for a long time, you might have just been asking the basic question, what is a slope? But today, our goal is to completely level up. We're going to move from simply recognizing a slope to actually writing out the mathematical equation of a line. And trust me, by the time we wrap up, you're going to see just how incredibly powerful that skill really is. All right, let's just dive right in by establishing a core metaphor. I want you to think of a line as a road on your coordinate plane map. You are the map maker here, and these equations we're about to learn, well, they're your tools. They are the precise, ironclad rules that tell us exactly which mathematical points belong to a specific road. So here is our roadmap for today's journey. 1. Mapping the basic roads. 2. Adding a tilted slope. 3. The master blueprint. 4. Where two roads meet. And finally, 5. The gateway to calculus. Part 1. Mapping the basic roads. Let's start with the absolute simplest paths a mapmaker can draw. Visually, it's actually incredibly easy to memorize this difference. For a straight up and down vertical road, the equation is literally just x equals a constant number. Why? Because no matter how high or low you go on that map, the x-coordinate never changes. On the flip side, for a horizontal road, y equals a constant number, because no matter how far left or right you travel, your y elevation is completely locked in place. To prove just how simple this is, check out these examples. X equals 2, x equals -4, x equals 10. Those are all perfect, straight up and down, vertical lines. Now look at the horizontal lines. Y equals 2, y equals -3, y equals 10. Completely flat. As long as one coordinate is completely locked in, the other coordinate is totally free to stretch on forever. Part 2. Adding a tilted slope. So, what happens if our map needs diagonal highways? To chart those, we use a brilliant little tool called the point-slope form. The formula is y minus y1 equals m times x minus x1. I absolutely love this one because it's literally named after the only two pieces of information you need to make it work: a single point on the line and the slope, which we represent with a letter m. And this shows just how effortlessly we can use it. Imagine you've got a point at the coordinates 2, 3, and a slope of 4. You literally just snap those pieces of info right into the formula. The y-coordinate 3 goes right next to the y. The x-coordinate 2 goes next to the x. And that slope of 4, it drops right into the middle. Boom! Y minus 3 equals 4 times x minus 2. Just like that, you instantly have a complete equation for that road. But hey, sometimes we start with different information. Enter our second tool for diagonal roads, the slope-intercept form, which is famously known as y equals mx plus b. Here, m is still our slope, but b is the y-intercept. And the y-intercept is simply the exact spot at coordinates 0, b where our road physically crosses the vertical y-axis. Let's put that into perspective with a quick example so you can see how powerful this is. If you see the equation y equals -3x plus 7, you really don't even need to do any math to visualize it. We immediately know the slope is -3, which means the line falls as it moves to the right. And we know it crosses the y-axis precisely at the number 7. You can instantly picture that map right in your head. Part 3. The master blueprint. Now that we've successfully mapped out our basic vertical and horizontal roads and our tilted highways, it's time to step back. Let's look at the master blueprint that governs absolutely all of them. This is the general linear equation format, ax plus by plus c equals 0. It's a first-degree equation where a, b, and c are just numbers. The absolutely crucial takeaway here is that no matter how messy or complicated the numbers might look when you first see them, every single equation written in this format is mathematically guaranteed to give you a perfectly straight line on your map. And here is the real aha moment. If we take ax plus by plus c equals 0, and we just solve for y by moving terms around and dividing by b, we end up with y equals -a over b times x minus c over b. Look closely at that. It perfectly matches our old friend, the slope-intercept form, y equals mx plus b. It's literally just wearing a disguise. And even if b happens to equal 0, you just get x equals a constant, which, as we already know, is a perfectly straight vertical line. Think of these 4 formulas as your ultimate mapmaker's cheat sheet: vertical, horizontal, point slope, and slope-intercept. Depending on exactly what information you have on your map, one of these 4 keys will unlock your equation. Part 4. Where two roads mold. In the real world, maps get crowded, right? So what happens when two distinct roads cross paths? Well, the source material spells it out perfectly. Intersection equals solving both equations together. Finding the crossroads isn't just some tedious arithmetic exercise. Think of equations as rules. Finding the intersection means finding the exact mathematical spot where both mathematical rules are true at the exact same time. Now that might sound a bit intimidating, but it's honestly a foolproof 3-step recipe. Step 1, set the two equations equal to each other. Step 2, use some basic algebra to solve for x. Step 3, plug that x value back into either of your original equations to find y. And that's it. Let's actually walk through one together. Say line 1 is y equals x plus 1. Line 2 is y equals negative x plus 5. At the intersection, both y values are completely identical. So we simply set them equal. X plus 1 equals negative x plus 5. Add x to both sides, subtract 1, and suddenly we have 2x equals 4. Divide by 2, and there it is. Our x-coordinate is 2. Finally, we just plug that x equals 2 back into our first equation, y equals x plus 1, which gives us a y value of 3. Our intersection is the coordinate pair 2, 3. This is literally the x marks the spot on our mathematical treasure map. It's the one and only point that perfectly satisfies both line equations simultaneously. Part 5. The gateway to calculus. Let's see how all of this builds into the ultimate destination of our mathematical map. Because learning the equations of lines isn't just some basic algebra exercise to pass a test. Everything we've covered today connects into a massive, beautiful system. The equations lead directly to the graph, which is the visual representation. The graph leads to intersections, and intersections are solved by combining those equations. It's an entirely interconnected mathematical architecture. This timeline perfectly maps out the evolution of your math journey. You start in year 1, mastering the slope of a simple straight line. Eventually, that transforms into finding a tangent slope, and finally, that directly unlocks the derivative. You are literally laying the bricks right now for higher-level math. Which leads us to this massive final thought. Calculus eventually takes this whole idea of a straight line slope and asks a truly incredible question. What is the slope of a curve at one exact point? You literally can't answer that without everything we learned today. The rules of straight roads are, quite literally, the key to unlocking the curves of the universe. Keep that in mind the next time you look at a simple y equals mx plus b. Thanks so much for joining me on this explainer, and keep exploring.